Okay, here's 2.1. We're going to be talking about functions. So we're continuing our talk about relations. Everything you see here is now one way to represent relations. Okay, some of these are functions and some may not be. So I want to talk about one of the easy ways that we can talk about is it a function or not when you're looking at a graph like these. But before we do that, this is a great time to bring up the difference between these two very different types of graph. We have this one here, which is an example of a discrete graph, and it is discrete because there are points that are separated, okay, with spaces between them, okay. And then you look at the other one over here, which is not simply points, but a continuous line. This is a continuous graph because there's an infinite number of points between any 2 points. So for example, like if you take here and here, there's an infinite number of points between those 2 points that I've highlighted on there for you. So this is a smooth continuous curve, and here you just have the points that are separated. So you've not connected the dots that we've put on there so much. So these typically come from equations, right? And this is generally just a list of points. Or we actually will learn later on how we can describe these more elegantly than a list. It's called a series or a sequence. So we'll get to that later. So for now it's a list. Alright, so obviously this one is continuous and this one is also discrete. Alright, so there's that vocabulary for you. Now I want to get to what I wanted to talk to you in the first place about, and that's this idea of having how to tell whether or not it's a function. So we have this thing called a vertical line test. And the idea is that real kind of casually, for every x, you know there has to be one and only one y. That makes it a function or not when you're looking at it. But in a graph, for every vertical line, it crosses the graph no more than once. There's that wonderful no more than. And it can only cross once or none. Otherwise, it would fail the vertical line test. You need to pass the vertical line test in order to be a function. Okay, so for example, let's take a look at the graphs that I've drawn. I'm going to pick up some new colors so we can draw some vertical lines. On this first one, if I start drawing vertical lines here, I'm crossing in 0 places, which is fine, until I get, of course, to this place right here, and I am crossing the graph in more than one place, in multiple places. So this fails. This one here fails the vertical line test. Therefore, it is not a function. Okay, so that's what the vertical line test can do for you. It's kind of an easy, quick way to describe this. So let's look at this second graph over here. If I start graphing vertical lines, drawing them on there, you see I only cross in one place every single time. And indeed, I could try forever, but I'll never find any place where it would cross the graph more than once. So this is going to pass the vertical line test. Therefore, it is a function. Okay, so this one was a function. If I look at this third graph over here, vertical line test, I'm only ever crossing once. So it is a function. It passes the vertical line test. And finally, this last one, drawing my vertical lines. Yep, I'm only ever crossing once, so it is also a function. Let's draw these same graphs on the next page. Okay, so here are those graphs again. I got to play a little bit with some importing a graph coordinate plane axis here. Worked pretty well, but it's a little too big to get all 4 on one page. So anyways, we talked about these, and now we're going to talk about having what's called a one-to-one function. And if a function was true, that for every x there's only one y, then this one over here was not a function. So if it's not a function, then it can't be a one-to-one function as well. One-to-one function is a subset of being a function. So your first test is it a function? So this graph failed here, this first one up here failed that. So must be a function is your first test. So try the vertical line test to find that out. Then you have to pass the horizontal line test. So it's the same kind of test, but this time we're drawing horizontal lines. So for this one, maybe I'll try a different color and see if we pass this horizontal line test. There it crossed only once. Here it's crossing only once. Here it crosses, oh no, 1, 2, 3 times. So if it fails anywhere, it fails the whole test. So this one here fails the horizontal line test, therefore it is not a one-to-one function. It is still a function, it's simply not a very specific kind of function, which is one-to-one. Okay, so that one fails. Then we can look at these other ones, draw a horizontal line, and see if they pass. It's passing, then you get to here and you say, oops, nope, that one fails. So it's not one-to-one. Okay, and then you look at this one, it is a function because it passed the vertical. Trying this horizontal line test, I only crossed once everywhere. So this one is yes, one-to-one function. This was the only one I had drawn. That would be both a function and a one-to-one function. Okay, so what does it mean to be one-to-one function as far as algebraically, in the words, and things like that? Let's go to the next slide. Okay, so when we're talking about a one-to-one function, first you have to ask yourself, is it a function? And we look at this and we say, for every x, is there only one y? Yes, so this right here is a function, like we'd always done before. But then we're going to look at it and say, to be one-to-one, it has to go the other way around as well. So for every y, only one x. Okay, so you kind of have to go both ways. Okay, so that's why it's 1 to 1. So you look at this and say, well, when y is 3, is there more than one x? And indeed, there is more than one x. When when y is 3, x could be 1 or x is 2. You have no way to know, did that y equal 3 come from x is 1, or did that y equal 3 come from x is 2? You don't have any way to know. So it's kind of like a little mystery. So you can't say that it's a one-to-one. To be one-to-one, it has to be perfectly clear. If I have this x, this is the y I will get. If I have this y, then I know exactly where it came from. Okay, so this one, because both of those come from the same x, I'm sorry, oops, let me back that up a little bit. Let's see if I can do that. No, it went this way, right? When y was 3, there were 2 different x's, so therefore this is not one-to-one. So that's how you're going to recognize it, sort of in that. To fix this, I'd have to have something like an x, a y, 1, 2, 3, and 4, and then I'd have to have 3, 4, 5, and 6. You know, all different y's that goes with those different x's like that. Okay, so if we're going to talk so much about functions, we need to come up with their own notation, of course. Okay, so in the old days, the old way, let me get back to some normal colors here, black. Back then, we used to say things like y is equal to 2x minus 3. Okay, that was a nice equation. Today, we're going to replace y with f of x. Okay, so y is simply being replaced by what's called, this is red, f of x. Okay, so I'm going to write it, f of x is equal to 2x minus 3. I've rewritten it now. This is called a function rule. It's the name f is just a name of a function, okay? It is not a variable, okay? We don't want to get that confused. And it is certainly not f times the parentheses of x, right? So that's not a times, it's just a notation, and we kind of put it all together, f of x. I want to describe the name of the function, and I want to make sure I'm describing this input value. I have to name the variable. So I have named the function and I've named the variable. The variable is the independent variable. Okay, it's kind of like the input. I put my x value in, and what comes out is my output, or my dependent variable. So if x is the independent variable, this whole thing right here would be the dependent. We often use that for y. This is a dependent variable, y. So, okay, I have now written this instead of using y. All I've done is use f of x instead. Okay, I can use any name. It doesn't have to be f for function. I could use g. I could use h if I'm talking about the height of something. I can use c. I can even use words if I really want to, okay? But right now we're just going to stick with some simple letters. Okay, in the old days we would have given you the equation, y is equal to 2x minus 3, and asked you to find y when x is 5. And what you would do is you'd be evaluating that right-hand side. It's kind of like a formula. Okay, and all you're doing is working on the right-hand side. Well, now we have function notation. Well, I'll tell you f of x is 2x minus 3. And now I'm going to ask you to find f of 5. So I have to give you the definition of the function, and then I have to ask you the question. Now what I've done is I have given you a value for x. So given x is equal to 5 now, okay? So what you're going to do is you're just going to make this substitution. Everywhere you see a x, you're going to substitute it with a 5. So f of 5, going back to this definition, is 2, but here's an x that will be replaced with 5, minus 3. So I'm just evaluating this function when x is 5. So nothing new. The important thing to remember is you're only working on the right-hand side, and you don't change it at all. It stays f of 5, and then you can circle that is equal to 7. We find this so much more, it's a much more elegant way to ask the question. It's a little more compact. And it's a much more elegant way to give an answer, because in this case I would have just said y is equal to, it comes out to 7. So there's my answer. But you see how you've lost the information that x was 5, okay? You have to go back into the question to figure out what x had been. So now here in my answer I've got all that interesting information right there looking at me. And the other thing is, when I go to graph this, if I wanted to graph this as a solution or give the answer as an ordered pair, it's really nice because this was your input for the x value, and this whole thing is equal to your output value. The y is 7. You're going to have an ordered pair, 5, 7 is a point that will go on the graph, because you're going to have a graph that has an x value. And on the y-axis, you're going to use f of x on the y-axis. Okay, so that 5, 7 is up here. Okay? So that's how you can change it from your function notation into an ordered pair quite easily, okay, with that information. Alright, I just want you to go ahead and do this one you-try example to make sure you've got an idea how to get this started. If you get the right answer, that's great. You don't need to hear the explanation, but you might want to go ahead and pause it. Alright, I'm getting a simple answer. F of 2 is equal to 5. And I got that very simply by everywhere there was an x, I'm replacing it with a 2. So over here, whenever there was an x, I replaced it with a 2. And then it's a simple matter of evaluating that right-hand side. I didn't change the left-hand side, and I just have to box my answer. Alright, we're done.